Warning: this project involves extremely high voltages. Please exercise caution if you attempt anything seen in this video. There is more than enough voltage and current to seriously injure yourself. This video also contains very loud noises, so headphone users beware. In this video, I'm going to show you how to build a voltage multiplier to get very high voltages, and a voltage divider to measure them. To start, let's look at the circuit for the voltage multiplier. For a simple voltage multiplier, we have only three components: a source of alternating current, or pulsed DC, a capacitor, and a diode. Now let's look at how the circuit actually works. To start, we have a transformer outputting 6,000 volts and the reverse orientation of the diode, so no current flows. When the polarity of the sine wave changes, the capacitor is now charged to 6,000 volts through the diode. Now when the sine wave flips again, the 6,000 volts of the capacitor will add to the voltage of the transformer, causing a total output of 12,000 volts DC. To achieve higher voltages, the circuit can be strung together, like this. Each pair of diodes and capacitors will increase the multiplication factor. So this circuit, which is the one I built, will output 4 times the input voltage. Here's the circuit in real life. The components must be rated for at least 2 times the input voltage, so at least 12,000 volts in my case. And to keep the video entertaining, here's the circuit blowing up a Pop-Tart wrapper. To prevent the high voltages from arcing earlier than the output, the circuit is potted in regular candle wax. I potted the container in 2 layers to save on space, but I only show the first one here. And here's the max arc length at around 24,000 volts. Now let's talk about the voltage divider. A voltage divider is simply 2 resistors in series, where the input voltage is across both resistors, and the output voltage is measured on the second resistor. The circuit works like this. The current through 2 resistors in series is the same, and is found by taking the voltage divided by the resistance. In our case, that means 1,000 volts, divided by a total resistance of 500,500,000 ohms. There will be 2 microamps flowing through both resistors. But we also know that current times resistance equals voltage, so 2 microamps times 500,000 ohms equals 1 volt. That means that if our meter reads 1 volt, we know the actual voltage is 1,000 volts. So let's see it in action. Here I bring the voltage all the way up to 25,000 volts DC. You can hear the corona discharge, which is the air being ionized at the exposed metal points. The divider works just as well at 6,000 volts AC. You can also tap points along the length of the divider. In my case, each resistor has a value of 100 megaohms, so the value of R2 changes in the equation. Notice that I do not bring the meter to the final high voltage point, because the output is the full high voltage being generated, which can destroy the meter. If you're building a voltage divider for large voltages like this, the total resistance must be very large to limit the current and heat generated in the resistors. Thank you for watching. For making it all the way to the end, here's a Franklin bell. The soda can is alternately attracted and repelled from each high voltage point as it builds up a charge. If you liked the video, consider subscribing. I'll see you next time.